So, lesson 2-6, and we are back to a fair amount of vocabulary. Sorry about that. Nothing I can do. First, ratio, which should not be a new word to you, but now it's time to have an actual definition. All a ratio does is it compares two numbers. For purposes of this example, I'm calling the numbers A and B. You can write out a ratio three different ways. You can make it a division problem, A divided by B. These are two dots, like in an analogy. A is to B, or you can just write out A to B. Your next word is rate. The rate is a particular kind of ratio that uses different units. For example, a ratio that compares miles and gallons. A unit rate is a rate with a denominator of 1. You'll get more clarity on that when we do problem 1. A conversion factor is, I started by giving you the examples because I think that'll make it more clear. This is a conversion factor, 1 yard divided by 3 feet, or 1 cup divided by 8 fluid ounces. They are conversion factors because they are ratios of two equivalent measures in different units. For example, 1 yard is equal to 3 feet. 1 cup is equal to 8 fluid ounces. A conversion factor is always equal to 1. Think about that for a second. This is the same thing in the numerator as it is in the denominator, so this is equal to 1. Unit analysis, the last vocabulary word. All that means is you are labeling the quantities in the calculations to help you figure out the answer. We will go over this in more detail when we get to problem 3. Now, pull out your book, page 118. So here we go. Though you may not have used the vocabulary words before, this is something that I know you guys have been doing for a long time. Problem 1 is called comparing unit rates. You are looking at the same t-shirts in 3 different stores. Store A is selling 2 shirts for $25, Store B is selling 4 shirts for $45, Store C is selling 3 shirts for $30. What's the best deal? You need to figure out the unit rate in order to answer that question. So, Store A, $25, 2 shirts, 1 shirt is equal to $12.50. Store B, $45 for 4 shirts, $11.25 for 1 shirt. Store C, $30 for 3 shirts, $10 for 1 shirt. Got it? Problem 1 simply asks if Store B lowers its price to $42, does the solution to the problem change? And I don't want you to write anything down in your notebooks, math-wise. I just want you to think about this. Right now, the way the problem was originally, which shirt is the cheapest? The $12.50 one, the $11.25 one, or the $10 one? Well, duh, the $10 shirt is the cheapest. So if Store B lowers their prices to $42 for 4 shirts, does that make the price less than $10 a shirt? You think about it, and then in your notebook, all you need to write down for me is yes, it's cheaper, or no, it's still more expensive. Problem 2. Now we are converting units and we are using that word conversion factor. This actually, I was skeptical when I first started looking this chapter over, but now I'm a pretty big fan. Take a look at problem A. They give you 330 minutes and they want to know how many hours that is. Well, you're going to use your conversion factor. Everybody knows this. There's 60 minutes in 1 hour. So, this is the conversion factor you've chosen to use. The next step, check out how cool this is. 330 minutes, 1 hour over 60 minutes. The minutes cancel out. When you cancel out the minutes and multiply this, you are left with 330 times 1 hour over 60. Divide 330 by 60, you are left with 5.5 hours. Because you canceled out the minutes, you're already left with the unit that you need. Now try this one. 15 kilograms, you're trying to turn it into grams. Choose your conversion factor, which is 1,000 grams for 1 kilogram. Multiply by 15 kilograms. What cancels out? Kilograms and kilograms. You are left with 15 times 1,000 grams over 1. 15,000 grams. Not bad. Problem C. 5 feet, 3 inches, and you're trying to convert the whole thing to inches. What's the conversion factor that you need? 12 inches for 1 foot. So don't multiply the whole thing, because you don't need to convert 3 inches into inches. You need to convert 5 feet into inches. So 5 feet times 12 inches over 1 foot. Feet cross out, feet cancel out. You end up with 5 times 12 inches over 1, which gives you 60 inches plus 3 inches, 63 inches. Yes, most of you probably could have done this in your head, but that makes it a good example to see how to do it with conversion factors, because it's very straightforward. You understand how it works. Got it, number 2. What is 1,250 centimeters converted to meters? For those of you that still can't remember how many centimeters there are in a meter, on page 801 in the back of your book, there is a table of equivalencies. It's actually a typo in your book. The book says it's on page 723. It's not. Page 801. All right, I know, some of you are just saying, do I really have to write this out? Because I learned in 3rd grade, all I had to do was move the decimal point. Trust me, just use this conversion factor because it's easy to practice on something that's simple. So first, choose your conversion factor. 1 meter over 100 centimeters. I'm multiplying by 1,250 centimeters. Now, for clarity, I wrote this out again. I do not expect this second step of everybody, but I just wrote it out so that you could see that I'm crossing out the centimeters, and then I combine what I have left. 1,250 times 1 meter divided by 100. Do that math, leave that label. I'm left with 12.5 meters. Piece of cake. This problem is also a great example of a unit analysis. Leaving these labels in here so that they help us figure out the answer is all they mean when they say unit analysis. I'm not sure why we need a vocabulary term for it, but for the moment we're going to go with it. So problem 3, a little more complicated than problem 2. Basically, we need to convert something from feet into meters. We have our conversion factor of 1 meter equals approximately 3.28 feet. So here's our problem. We cross out feet. I should say feet cancel out. We end up with 815 times 1 meter over 3.28. Divide it out, you end up with approximately 553 meters. Then they go through the process to check it. Let's turn the page and do the next problem. Problem 3, letter A. We know that a building is 1,450 feet tall, and we want to find out how many meters it is. So here's our conversion factor, 1 meter over 3.28 feet. Keep all your labels in place, because then feet cancel out. You end up with 1,450 times 1 meter over 3.28. Divide 1,450 by 3.28, and you end up with about 442 meters. Now, do a quick use your brain check. There are about a little over 3 feet in 1 meter. So when we convert this to meters, it should be a little over a third of what it is right now. Is 440 approximately a third of that? Yeah, it's pretty close. It's definitely not way too big or way too small. So checked. Done. Letter B. We have actually something that people need to do rather frequently. If you need to change money from $1 from dollars to euro, you need to know the exchange rate or the conversion factor. Here's the conversion factor they give you, 0.63 euro to a dollar. So before you even start, hopefully you're thinking, all right, so if I have $325, but there's not even one full euro in a dollar, my answer is going to be smaller than 325. So I have crossed out the dollar signs. We are left with 325 times 0.63 euro, which gives us the answer of 204.75 euros. That's the amount you can get for it. Problem 4 is where we really pull everything together, and we're going to convert rates. Given that a student ran the 50-yard dash in 5.8 seconds, what speed was he running in miles per hour? So we need to use a couple of conversion factors because we need to convert yards into miles. We also need to convert seconds into hours. So we need 2 conversion factors, and this is where your labels become incredibly important. Take a look at what we have down here. 50 yards in 5.8 seconds. We're going to multiply by the first conversion factor. 1 mile has 1,760 yards in it. And then we're also going to multiply by the second conversion factor. 1 hour has 3,600 seconds in it. So you're multiplying what they gave you, 50-yard dash, 5.8 seconds, by both conversion factors. Okay? They are on that page, and some of them at least are on that page in the back of your book if you need them. Cross out what is in common. So this yards cancels with that yards. That seconds cancels with that seconds. So we are left with 50 times 1 mile times 3,600 divided by 5.8 times 1,760 times 1 hour, which works out to this. And then you divide it out. It's approximately 17.6 miles per hour. If only we actually could run that fast for that long. Got it. Number 4. So an athlete ran a sprint of 100 feet in 3.1 seconds. I wish I knew who was a sprinter so that I could do a shout out. We'll make Willow a sprinter today. All right, so if Willow's running a sprint of 100 feet in 3.1 seconds, at what speed was she running in miles per hour? So we're going to have to convert from feet into miles and from seconds into hours. Round to the nearest mile per hour. Let's grab our notebooks and set that up. 4A, when you set it up, should look kind of like this. Here's the information they gave you. 100 feet run in 3.1 seconds. Willow was flying. We need a couple of conversion factors. We need to know how many feet are in a mile, and we need to know how many seconds are in an hour. You multiply by each of those conversion factors. And make sure that your fractions look kind of like this, because if you had flipped either of these, your math is not going to work out. I wrote this out again to make it a little clearer when I started canceling units. Feet cancel with those feet. The reason they cancel is because one's in a numerator, one's in a denominator. That's how you know if your fractions are upside down or not. Seconds here cancels with seconds there. Again, one's in the denominator, one's in the numerator. Work through the multiplication. 100 times 1 mile times 3,600. Everything else up here canceled out. In the denominator, 3.1 times 5,280 times 1 hour, which works out to 360,000 miles over 16,368 hours, and when you simplify that, you end up with approximately 22 miles per hour. Nice going, Willow. Letter B, I'm going to ask you to work out on your own. They ask a really great question. They say, what if in the original problem, they used problem 4 in the book, but it would be the same with this problem too. What happens if instead of multiplying by 3,600 seconds in an hour, you use two conversion factors for this? What if you use 60 seconds in a minute and 60 minutes in an hour? So what I want you to do is work through that on your own in letter B and see what happens with the answer, because I want you to feel confident. Can you do it that way if you are not certain of that single conversion? The rest of your homework for tonight, we're going back to the lesson check problems. So on page 121, it's just numbers 1 through 8. That is it. Good work. We seem to have taken a left turn from straight algebra. I'm not sure when we're going to get back to it.